Hey guys, Miss Cook here. So Miss Jean Perry has taught you about scatterplots and just the basic information. Now I'm going to teach you a little bit more about them and talk about linear data and nonlinear data. But before we do that, we got to review and go over the word linear. So if you are to look at this word right here, it says line. So we're going to say linear equals line, like a straight line. So that means nonlinear is equals not a line. And when I mean a line, I'm talking about a straight line. So if we go to the data, I'm going to draw a line. Kind of think of all the lines that slope due did. So I'm going to go up first. This would be linear. It'd be a positive line. If I go down, this would be a negative linear line. This type of line over here would be an undefined line. And we also have that zero line. These are all of the different ways that lines can be linear. So now I'm going to go over nonlinear. So I'm going to get a nonlinear, several different lines. So you have one like this. It goes down and then comes back up. This kind of looks linear at first when it goes down, but then it comes back up. It's not a straight line, so this would be nonlinear. Or you could have something that looks like this, where it starts and then it slowly starts to come around. That would be nonlinear, or something like this, where there's definitely like a pattern to the line, but it's not a straight line. So these are all different examples of nonlinear. So what we're going to do next is look at some data. And all of these graphs you're going to see right now are linear lines. We could have a positive linear data line or negative. And that's just about slope. Remember, puff, puff, positive. Positive means goes up. Negative, nice, negative means it goes down. So this line, this data, I'm going to go back to that red color. This data right here on this graph is linear because if I was to try to see what's going on here, I can make that line of best fit that Miss Jean Perry talked about. And look, right here, right in the middle of all of my data, I notice that it's all going up in a straight line. So this would be a linear graph. Now, this one's a little bit harder to see. But it is linear because if I go that line of best fit again, look what happens. It becomes a negative linear line. So this is linear because that is all going down together. This one's a little bit easier to see than the one before. You make that line of best fit with the data. So like the line best fit members cuts my data right in half. We notice that it's linear. It gives us a straight line. This one's going up, meaning it's positive. Right here, if I cut this data right in half, this one's a little bit harder to see, but it's still all consistently going down. So these are all different examples of linear scatter plots. Now, nonlinear is probably a little bit easier to tell because if I was to draw a line in the middle of this data, look what happens. It goes up and then goes back down. So nonlinear. This one, well, it kind of looks like it could be linear, but look what happens to my line when I go in the middle. It starts to curve. So these are both examples of nonlinear scatter plots. And then we have another one called no relations. And this no relation is kind of meaning my data is all over the place. There's no way I could cut it. There's no good central location. So this should be no relationship. And same with this. My data is all over the place. There's no pattern. There's nothing. No relationship. Now, checkpoint. Is the set of data linear or nonlinear? Ask yourself. I hope you all said linear because it is going up. My data is all going up together. Another checkpoint. Linear, nonlinear. Well, actually, it's no relationship because it's all over the place. And then our last one, linear, nonlinear. Think about it. I hope you all say nonlinear because it goes down and then up. Good luck on your guys' quiz. We miss you. If you guys have questions, let us know.